Hello everyone, I am Pranav Raj from Department of CSC IML. Today I am going to explain about the problem island count. The island count is a problem also known as number of islands. Is a classic algorithmic challenge where you are given a 2D grid consisting of one is land and 0 water. The task is to count the number of distinct islands where an island is a group of adjacent land sets connected horizontally or vertically, but it's not connected diagonally. Remember, each island is surrounded by water, and the entire grid is assumed to be surrounded by water as well. The problem statement, it will given that an 2D binary grid of size m cross n where each cell contains either one land which is land or 0 which is water. The definition is an island is a group of connected land cells connected horizontally or vertically. The main aim is to return the number of islands in the grid. The output needs to be the number of islands. The adjacency, only horizontal and vertical connections count, diagonal connections are ignored. Algorithmic approach, the most common solution uses depth first searches DFS or breadth first searches BFS, where where AI A1 is found. It triggers a depth, depth first search or breadth first search transversal to mark all connected oneness as listed by changing them to 0 or using a separate visited structure, ensuring each island is counted only once. For each unvisited island, which is 1, increment the island counter and explore all connected land cells. For example, if there are 3 islands, top left 2 cross 2 block and single cell in the middle, bottom right pair. This example of 5 cross 5 grid with 3 islands. The island 1, 0, 0, 0, comma 1 and 1, comma 1. The island 2 is 0, comma 4, 1, comma 4, 2, comma 3, 2, comma. The island 3, 2, comma 0, 4, comma 0, 4, comma 2, 4, comma. The total count of island is 3. Iterate through each cell in the grid. If the cell is 1, increment the island counter and perform DFS or BFS to mark all connected ones as visited. Continue until all sets are proceeded. The time and space complexity, complexity O of m cross n, since each cell is visited at most once. Space complexity O m cross n in the worst case due to the recursion stack in DFS for a single large island or the queue in BFS. This approach ensures all islands are counted efficiently. If you need a specific code implementation, a visual example variation like counting islands. Key insights and approach. The graph problem. Graph cells from a graph with adjacency relations connected components. Each island is a connected component in the graph traversal. Use DFS or BFS to explore all cells in an island. The visited tracking, it marks the cells that are visited to avoid revisiting. The counter logic is the incrementation of counter each time new island is discovered. So we need to increment the count every time we discover a new island. So in the grid, dimensions satisfy 1 less than or equal to m and n less than or equal to 300. In most standard implementation, this is used. Each cell in the grid is either 1 or 0, which is land or water that we have discussed. Only horizontal and vertical connections between land cells are considered. Diagonal connections do not form part of the same island. The entire grid is surrounded by water, so you do not need to handle boundary conditions beyond the grid edges. The input and output is input a 2D grid, that is a list of lists of characters or integers where I is land and 0. 1 is land and 0 is water. Output, an integer representing total number of islands present in the grid. It is the output. The problem is widely used in coding interviews and competitive programming to access understanding of graph traversal and connected components. We move on to next slide. Algorithm DFS that we discussed, depth first search. It will iterate through every cell in the grid. When finding unvisited land 1, start depth first search from that cell. Recursively explore all 4 adjacent cells, up, down, left or right. Mark each visited cell to avoid processing. After DFS completes, increment island counter by 1. After completion of depth first search, you need to increment by 1 and you need to repeat it. The common constant that often causes incorrect solution in the number of islands problem include: it will not handling grid boundaries properly, ignoring visited cells, and considering diagonal connections, mutating the input incorrectly or not at all, and wrong direction traversal. Then we move on to algorithm BFS, which is breadth first search. Key differences from depth first search to breadth first search. In breadth first search, it uses queue instead of recursive, and it's an iterative approach, and it explores nodes level by level from starting position to the end, and it's better for systems with limited stack space, the space time by space complexity. It is prepared when you want to limit recursion depth. The complexity analysis, the time complexity O of m cross, where m is rows and l is columns, each cell visited exactly once during traversal. Space complexity is same, O is m cross n. DFS, in DFS it is a recursion stack, in BFS it queue storage. In the worst case, entire grid is one island, so there is no water. The applications and real world uses, it is used in geographic information systems, which is GIS, is for analyzing geographic features and regions, and we also use in image processing, connected component labeling and image segmentation, and network analysis, finding connected clusters in social networks across the globe. It is very useful in network analysis as well, and it's also in game development, flood fill algorithm for paint tools and level generation. And move on to next slide. Edge case and consideration. If empty grid returns 0, all water return 0. If all land 1, return 1, it is single island. Single cell grid return 1. If 1 or else 0. Diagonal cells are not connected. It's only 4 directional. Grid modification or separate visited array memory trade-off. Move on to next slide. It's the variation and related problems. Max area of island. Find the largest island's area. Where you, after finding a island, you need to find the largest area, largest island's area, the number of enclaves, count land surrounded by water, and the 8 directional connectivity include diagonal connections, in distance of nearest cell, multi-source BFS problem, the rotting oranges with time-based spread simulation. Key takeaways and best practices. Always validate boundaries before accessing grid cells. Choose DFS for simplicity or BFS for iterative approach. Either both you can use. Consider memory constant. Stack for DFS, queue BFS. Test with extreme cases, empty, all water, all land. You need to test every case with only water, with no water, no land, and with only land grids. The pattern recognition. This is a template for connected components. Common mistakes to avoid: forgetting boundary checks, index error expectations, not handling grid boundary properly, failing to check the boundaries of the grid when performing DFS, or BFS can cause out of bound errors or incorrect results by accessing invalid indices, ignoring visited cells, not marking visited land cells, leads to recounting the same island multiple times, inflating the island count. It is crucial to mark cells as visited or change their value from 1 to 0 during traversal to avoid this. Considering diagonal connections. Counting diagonal adjacent ones as part of the same island violates the problem definition and causes incorrect island counts since only horizontal and vertical adjacency counts. Mutating the input incorrectly or not at all. Some solutions mutate the input grid to mark unvisited cells. If this is done incorrectly, or if the problem expects the input to remain unchanged, results could be wrong and the wrong direction transfer. It will be miscounting islands, omitting. Addressing these contrasts carefully ensures. Then the conclusion, classical graph transversal problem. It is solvable with DFS or BFS approach, O of M cross and time and space complexity, foundation for understanding connected components. Thank you.